Hello everyone. In this video, we will continue to examine topic 7.3, the structure of matter, and in particular, we will describe the Rutherford Geiger Marsden experiment. So in the previous video, we were sort of running through a brief historical survey of our successive models of the atom, right? And we had gotten up to J.J. Thomson's plum pudding model. At this point in history, due to Thomson's experiment, we understand the atom to be made of both sort of positive and negative charges, but J.J. Thomson discovered anyway, that the negative charge was composed of small, dense packets that we now understand to be the electron, that we now call the electron. And he did this by measuring the charge to mass ratio of the negative particles in the atom. Discovered that the negative charge in the atom can be viewed as these sort of tiny little plums in sort of a positively charged smear of pudding. That is sort of how to interpret this model. The next step hinged on an experiment that is now known as the Rutherford Geiger Marsden experiment. And this will take us sort of to a semi-modern understanding of the atom. In this experiment, Rutherford Geiger and Marsden shot high-energy alpha particles at a thin piece of gold foil. This experiment is sometimes known as the gold foil experiment, and you need to be able to both describe the experiment in detail and describe its implications for the atom, sort of what it meant and what it implied. So the high-energy alpha particles were taken from an alpha emitter and then accelerated through a significant potential difference and shot at this thin gold foil. Now, what was expected? Well, these high-energy alpha particles were, these dense helium nuclei. At this point, they're understood to be pretty heavy things, right? They're 4 nucleons each. And we knew at that point what their mass was, although we did not understand that they were helium nuclei at this point. And we understood that they were, when we accelerated them, sort of very, very fast and powerful. And so what we expected, what Rutherford, Geiger, and Marsden expected when they did this experiment was to see small deflections at most, to see, maybe this high-energy alpha particle would be slightly pushed askew by the gold atoms in the thin gold foil. But if you do the calculations on sort of what you would expect from an evenly distributed positive charge within that atom, you get small deflections at most. The idea is that these alpha particles are huge, they are highly energetic, a lot of kinetic energy, and they are moving very, very, very quickly. Now, the actual result of this experiment did involve both of the things that we just described. So some of those high-energy alpha particles did sort of make it all the way through, and there were some small deflections, for sure. But there were also some, not huge numbers, but significant, very, very large angle deflections. This alpha particle is shown here to sort of reflect more or less off that thin gold foil. From Rutherford's own words here, it was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. And that's crazy. So this was sort of crazy at the time period. But the model that explained this, so the model that he came up with, is one where the positive charge in the atom is also in a small, densely packed chunk. So all or most of the mass and the positive charge was located in the dense center of the atom rather than being spread out as in the plum pudding model. This description, where all or most of the mass and the positive charge was located in that dense center, is now known as the nucleus. It's what we call the nucleus of the atom. And this experiment can be described as the discovery of the nucleus of the atom. It led to the discovery of the nucleus of the atom, because the only way to get these very, very large angle deflections is if your incoming alpha particle is literally colliding with particles that consist of virtually all of the mass and all of the positive charge in the gold atoms. And this led to what I affectionately call the Jimmy Neutron model of the atom, otherwise known as the nuclear or planetary model of the atom. This is the model of the atom that is traditionally introduced in elementary science classes, where you have electrons sort of visually depicted as orbiting that central nucleus with a very, very tiny but massive positive nucleus.